Welcome, Denis. Yes.
Thanks, guys. Happy to be there to speak about advanced authentication pattern at the edge. So the idea is really to speak about how you expose securely your applications running on Kubernetes, if you want to get a better understanding about the topic today. So I am Denis Jannot. I am working at solo.io. If you don't know who we are, hopefully you will know at the end of the session. And so I'm taking care of the field engineering team in EMEA, and we always look for new talents, so don't hesitate to come and speak with me after the talk. Obviously, this will be very fast, kind of introductory slides. I have a lot of demos at the end as well. But the main idea is that obviously, people go from monolith to microservices. Nothing is new. You tend to run these microservices on Kubernetes. Again, nothing is new. I would say everyone would agree with this. But then one of the first things you try to do after you have your services running on Kubernetes is to expose them so that they can be accessed from outside of your cluster, right? And you generally start by using something like a standard Kubernetes ingress, controller like Nginx or HAProxy or something like that. And it does the job, right? I mean, at the beginning, it's fine. I can expose my services. I can secure the access through HTTPS, for example, and that does the job, right? But what happens is that you start to have more and more services running in your Kubernetes cluster, and you start to look at how these applications are secured, and you start to see that they want, like if you have a web front end, for example, you probably want to authenticate your user with OIDC workflow, for example. If I have like an API that is exposed outside, I want to secure the access to this API with API keys or with JWT tokens or things like that, right? But everything is really implemented directly in the applications, right? So there is nothing that is done by this ingress. It's really the application that configure everything. And it's not basically the main goal of the application team in general, right? They want to implement the business logic. They don't really want to implement like OIDC workflows, right? That's not their main thing, right? And it's very opaque as well. I mean, the security team, for example, if they want to know how everything is secured, they have to go and talk to all the teams one by one and discuss about how they have implemented all these different things, right? So that's one challenge. But also, there are still some security mechanisms that you need to put in place. Generally, you do that at the beginning outside of the cluster. You can, apply rate limiting, for example, so that you want to make sure that you protect yourself if someone tries to abuse your service, or perhaps you want to apply some WAF rules, right, so that you can protect against some kind of attacks, right? For example, you've seen like these attacks with Log4Shell or others. You have to update your application to protect yourself. Waiting for that, you want to go to your web application firewall and put some rules there to get some time to update all your apps, right? So it's something you do outside of the cluster, and that means that basically the application team cannot easily automate this, right? They have to talk to another team that will implement these different security measures for them. So that's kind of a summary of what I've just said. And basically what we start to see coming more and more since, I would say, a couple of years probably, is people trying to move these things out of the application so that it's not like the application that has to implement all these workflows, but instead they deploy an API gateway on Kubernetes. Why on Kubernetes, I will explain in a minute. But they deploy this API gateway and they configure all these authentication mechanisms at that level, right? So that the application doesn't need to care about that anymore. They still want to know who is the user that has been authenticated, right? And we will show you that in the demo, what are the kind of workflow that we see in that case. But also what's important is that even if the application team doesn't want to implement the code directly in their application, they still want to define how the user should be authenticated, right? There's still something that they want to have control on, right? So that's why having like an API gateway that is Kubernetes native, which means that you can drive the configuration of this API gateway through Kubernetes objects through YAML. Makes a lot of sense because I moved all the complexity in this API gateway, but I still allow, if I want, I still allow the application team to define with some YAML how they want the authentication to be performed on their behalf. So I hope it makes sense. So that's one of the benefits, is obviously that the application team can focus on the business logic and not on this mechanism. The other thing that is quite nice is that this kind of API gateway can do this rate limiting, or they embed a web application firewall. So they can do all these things that were done before outside of the cluster. And because it is done by this gateway running in Kubernetes, again, the configuration of the WAF, for example, can be defined by the application team using YAML, which is pretty good, right? Because if you want everyone to go and follow like a GitOps approach and describe everything as code, if they can also define all their security mechanism that way, that makes their life a lot easier, right? So again, you do all these things in this API gateway. You can decide if it's like a team that is dedicated for managing these security rules, or if you want to delegate that to the application team. But at the end, the security team can go into the API gateway configuration, and they can see everything. They can see exactly how each application is secured, right? They don't have to go back again to each team one by one, tell me how you configure this and this and that, right? They can go to one place and they see the overall configuration and how everything has been secured. I spoke about Kubernetes native, so I say obviously the number one use case would be like I want to expose my services that run on my Kubernetes cluster, but not only, right? If I want to go to this GitOps approach, implement all this workflow, I want to do that for my modern application that I run on Kubernetes, but I also want to do it like for my legacy environment, right? So it's quite nice if I can express all these configurations through YAML, even to expose services that are outside of my Kubernetes cluster, right? So it's not only for exposing services running on Kubernetes, it can be for services running on VMware, or like on bare metal server, on Lambda functions, or whatever. So again, I think I've been through that already. So my talk is really focusing on this, right? Like how I secure the access to my application. But I just want to highlight, even if I will not focus on that in this talk, that it's only part of the problem, right? Because as soon as I have secured the way I expose my application outside of my cluster, I still didn't do anything about how my services inside the cluster communicate together, right? So if I have a service A that needs to talk to a service B in the same cluster, by default they can, right? And if you want to enforce some rules there, right? Again, you need to do that in the application, right? If you want to have some stronger authentication, you need to do that in the application itself. If now my service A is in cluster 1 and my service B is in cluster 2, it becomes even more complicated because I need to expose my service that's running on cluster 2 through an ingress, for example. Then it can be accessed by any service, not only service A. So I need to put, like, I don't know, a JWT token in my request sent by service A. I need to implement the check of this JWT token on service B, you see. So there are like also a lot of concern about how I secure the communication between my services. And this is something you would address with a service mesh, not with an API gateway. Why I speak about that now? Because these two things tend to come together. Not always. You have some people who really focus more on this securing the service-to-service communication with the service mesh first, and they still do all the authentication on the application level. Some, they start with the API gateway, and later on, they look at this service mesh, and some, they just go and try to fix these two problems at the same time, right? But I'm going to show you the demo where you can see everything combined together. So here, what I will do is that I will do a demo that will be based on the Envoy proxy. So I don't know, I assume most of you are familiar with the Envoy proxy. If you are not, you can think about it like a next-gen, HA proxy or Nginx. It's kind of the same performance. It's also written in C++ and so on, but it has been really built to be programmed by a control plane, to be programmed by something else, right? So it's like, it's not like you provide like a configuration file, and when the proxy starts, it looks at this configuration file and applies these rules. It's really waiting for some control plane to configure it through APIs, right? So that's the way Envoy works. It's part of the CNCF. It's very popular, obviously, and also the foundation for all the service mesh technologies, right? So if you look at a service mesh, in general, in 90% of the case, you will see that Envoy is a foundational piece for this service mesh. So why I say that? Because I say you want to expose your service securely with an API gateway. You want a service mesh to secure the way services communicate together. Even if you start with the API gateway first and you don't care about the service mesh yet, you will need a service mesh at some point. So it's probably better to start with an API gateway that is using Envoy, right? Otherwise, you would have like 2 different technologies to manage, right? So the way Envoy works is that you have this architecture where you have what we call like a filter chain. So inside Envoy, when a request comes in, it goes through a series of filters. And you have some filters that are already built in Envoy. They just come with Envoy itself, with the core Envoy. And you can build your own additional custom filters in C++ that will be really high performance filters. You can also do some other things. I will not go through all the details. You can use things like WebAssembly, but it's more for really custom things because the trade-off is that you don't get the same performance as like a custom C filter. But you see the idea, right? The request comes in, it goes through this series of filters, and each filter can modify the request, deny the request, or decide where to send the request, right? And some of these filters, they also need to communicate with an external component. Let's say I say I want to authenticate my users when they connect to my front end. I put this API gateway based on Envoy. The request comes in. It needs to talk to this external authentication server that will implement the OIDC workflow, for example, right? And then when this workflow runs, then it can decide if the request should be allowed or should be denied, right? There is another case, for example, I want to apply rate limits. It's not like Envoy itself that will be able to decide if I have reached a limit because you can have multiple Envoy instances running for high availability. And you could not do, if you would do rate limit at the Envoy layer, right, directly, you would only be able to keep track of the requests that have been received by this specific Envoy, right? So generally, you have this external rate limit server that can decide if the request should be allowed or not, right? And then you have these custom filters, and then you have this control plane component that needs to configure Envoy itself. So at Solo, we have our API gateway that's called GlueEdge that we have since a long time. That basically is this control plane, is coming on the enterprise version with this external authentication server and rate limit server. That means that you don't need to build your own servers. And it comes with a lot of interesting custom filters. For example, a filter that can allow you to do transformation with regular expression. Like I take a regular expression on this header to create a new header, or I look at the data in the body to create a new header, or these kind of things. You have like a filter for web application firewall. You have all these custom filters. So normally, what I would do, I would tell you this is the API gateway that you can use for what I described before and doing a demo with it. And that's what I was doing when I did this talk in the past, right? But we've done some new things that I will show you now that I think are quite interesting. But just before I go through that, like again, I wanted to highlight this Kubernetes native idea, right? You configure 100% of it through CRDs, right? You don't have a database. There is absolutely zero database in the product. So what I'm going to do differently this time? What I'm going to do differently is that I told you that we have like this API gateway on one side for securing the access from outside, and we have this service mesh that can be used to secure the communication between services, right? And if you look at Istio, which is the most popular service mesh, it comes with a gateway, right? You have these Istio gateways. So you could say, in that case, that's fine, because if I take Istio, I solve my problem of service-to-service communications, and I have an API gateway that looks really cool, right? But this API gateway basically doesn't do much than an ingress. Like, it's really a very basic gateway that just do mostly routing, like not only, but mostly routing, right? But it's based on Envoy as well, right? Like the glue edge that I described before. So what we did is we took all these components that we have in glue edge, like the external authentication server, the rate limit server. We deploy them on Istio. We take all these filters that I told you about before, like the transformations, like the WAF and all the stuff. We replace the image of the Istio gateway by our image, which is exactly the same, but with this filter inside. And we have this glue mesh management plane that is exposing an API that is very easy to work with, right? So basically, the user will be able to define with YAML very easily what they want to achieve, and glue mesh will translate everything into Istio and then Envoy so that you can achieve the same benefits. But let's do a demo. I mean, I think I did some slides. Now it's time for demoing all these things, right? So what I did here is I have like three clusters running here. In fact, you see more, but I have like the management, cluster 1 and cluster 2. So the management is where I have my management plane, so glue mesh. And cluster 1 and cluster 2, there are two different clusters where I have Istio. In this talk, I'm going to just focus on one cluster and showing you how you can expose the services, but the idea behind glue mesh is to really allow you to do all this cross-cluster communication easily as well and so on. So here, I have like something we call like a root table. So if I look at the context cluster 1, I have a root table here, which is like allowing the end user with YAML to express how they want to expose their application outside, right? So here it's very easy. I say I want, whenever I have a request coming for /get, I want to send a request to this Kubernetes service that's called inmesh in the HTTP bin namespace, okay? So by submitting this, the user submit that, and glue mesh translate that in something we call a virtual service in Istio. And you can see here, it looks quite similar, right? So you would say, why I don't create directly this virtual service? Because you can do a lot of multi-cluster things, and it would take me a lot of time to explain all these details, but bear with me, you will understand the value very quickly. So here, I just expose my service outside, and I can access this /get, you can see, and this is the HTTP bin image. A lot of you are probably familiar with it. What it does is just display you what are the header that came with the HTTP request. So the request has been sent by my browser. It's very simple. It's just a /get. But you can see already that Envoy has added some additional information, right? For example, because I am part of the mesh, Envoy has added the fact that the request is coming from the gateway, right? So I can know as the application owner, I can see with the header who was the sender of this request, for example. So now let's start to secure things, right? So the way we are going to secure it is we are going to start by applying like a XAuth workflow based on OIDC, right? So to do that, we have like multiple different CRDs, right? Multiple different CRs we can create, like this one that's called XAuth policy. And you can see here what I define. I say, I want this policy to be applied to all the routes that have this label. Okay, so it's really nice because I can reuse it, right? If I want to apply like this authentication in 3 different routes, 3 different paths, I just have to put this label in all these different routes and it will be applied to it. And then I can define different steps. In that example, I say I want to do authentication with OIDC. These are my information. Like this is where I run my Keycloak instance. If you're familiar with Keycloak, right? It's an open source identity provider. So I have this Keycloak identity provider that I use to authenticate my user. And I say I want to, after I authenticate with OIDC, if you are not familiar with OIDC, you get a JWT token. Basically, you get a JWT token that can be used to get information about the user that have been authenticated. And here I say I want to create a new header that will have this JWT token. And I want also to have a second step, which is about authorization. So I want to authenticate with OIDC, but then I want to authorize or not the request based on some information on the user. And for that, I use something called OPA. I don't know if you're familiar with Open Policy Agent. In that case, what we do is that we don't need an OPA server. We just embed the OPA libraries directly in our Xdot server so that it will verify, like you can see, it's the language that is used in OPA is called Rego. So here I create a config map in Kubernetes, and I say my rule will be I want to extract from the JWT token the email claim and check if it ends with solo.io. If it doesn't end with solo.io, I don't want to allow this request. Okay? And if I go back a little bit, I can show you the way I deployed Keycloak. It has been with several users, and the users here, you see, user 1 has an email that finished by example.com, so it should not be allowed. And user 2 has an email finishing by solo.io, so this one should be allowed. Okay? So how do I apply it? I already created these objects in my cluster. So the only thing I need to do is updating my root table here so that I have my label in my root. You remember I said the policy will be attached to all the roots that have this specific label. So I create this, and now if I try to refresh this page, oh, not in the right one, I am redirected automatically to Keycloak, and if I do user 2, that will be working well because it's the right email. If I would try in incognito mode here, and I will try with user 1, oops, the copy and paste never works here. Oh, I have to learn German, I think. So that should be that. And then if I use user 1, you can see it's denied, right? And I could make it better, right? I could make a page that say why, you know, and all these things, right? But it's just a basic example. But you see also when you look at the headers, you see something has been different now, right? I have my JWT header that contains my JWT token, and you know this JWT token has the email, for example, because we've checked what was the email value, right? So the first choice would be, that's fine. Now my application, they know that the user have been authenticated on their behalf, and they could implement, like decode the JWT token and validate who is the user and do something with it, right? But we can make their life easier. So what we are going to do, we are going to create another object here that's called a JWT policy. And in the JWT policy, we are going to say we want to validate the JWT token itself, and we want to extract the claim email and create a new header from it that will be called X email. So it's a lot better for my application because they don't need to decode the JWT token by themselves and stuff. They just have this data that they care about, right? If they just want to know who is the user, that's definitely good enough for them. And again, I say I want to apply it on all the roots that have OAuth equal true. So I don't need to change anything, right? Because I already have my root which has this label. And what's quite interesting, I can also define where I want to do this, right? Because if I configure Envoy so that it will try to do this before I authenticate the user, it will not work, right? So you can really decide in which order you want to do these different things. So I'm going back here, and you can see now that if I refresh, I should have this X email somewhere coming. Is it here? No. Did I do it correctly here? Oh, I know what I did wrong. So give me 1 second. I forgot that I don't have this variable in my laptop. So just give me 1 second. So that should be this. And that's it. Port key clock. That should be good as well. So let's see. That should be better now. Yeah, so you see, I removed my Jannot header because my application doesn't need to know all the details anymore. They just want to know who is the user. And here I have this X email that tells me who is the user, right? So the application should be happy. They know who is this user, right? So that's a second good step, right? Making the life of this application team easier. Then you can do more than that. So the next step you can do is you can add this transformation filter. You remember I said we have this transformation that allows you to use like regular expression. It's based on Inja templating for people who know that. And you can say here, again, I want to do that after I extract this new X email header. And I want, you see, to use this regular expression to basically use only the domain name, right? So if my email is user2.solo.io, I just want to extract solo.io, right? And that will be a new header called organization. So you could tell me, okay, that's good. Good to know that we have this kind of transformation possible, but the application itself could also just extract that from the email. I mean, it's probably not so useful in that context, but you will understand why I'm doing that in a second. Yeah, so here you see now I have my X organization, solo.io, right? So I have this new header based on this transformation. So why it's quite nice to be able to do this? Because now I want to apply rate limits, right? And how do you apply rate limits? You apply rate limits based on some information that you can trust in the request, right? If you, for example, say I want to apply rate limit based on a special header, then it's very easy for anyone to send a request with a different header, and then they will have bypassed your rate limit, right? So there are a lot of things you cannot really trust in your request coming in for applying rate limits. But now, if I apply rate limits based on the organization, I get two benefits, right? The first one is it can be that I apply not a rate limit per user, but I apply a rate limit for an entire company. So I tell you, you can send 1,000 requests per hour overall. I don't care if it's one of your users sending all of them or like kind of mixed users, right? And the second benefit is because I'm going to apply it based on this header here, X organization, I trust this header, right? Because this header is computed from a secured Jannot token, right? Even if the user would say X organization fake, when it goes through these envoy filters and it does all the things, it will override it with the right one, right? So it's like a secure rate limiting that you get there, right? So I'm going to, again, everything here I already created. I say I want to create a new descriptor called organization from this header. And then I want to say that I have 3 requests per minute allowed for this organization solo.io. So I already created these objects. The only thing I need to do here is, again, if I look at this policy, I say I want to apply this policy to all the routes that have this rate limited equal true, right? So I just need to go update my route table, and that will automatically, just adding this rate limited equal true, it will attach the policy to it. So I'm doing it now, and if I go here, I should still be able, for some time, until I reach my limit. Which should be 3, I think. Let me check what I did. Oh, no, I know what I did. I did apply this delete before. So in fact, I deleted this object. So I told you that I already have them, but it's not the case. So I apply these guys. So this one here. You can also define which server you want to use. You could have different rate limiter for different teams or these kind of things. And now I think I have all my stuff here. And you see now I am rate limited, right? So I get a 429, means I got like rate limited. Okay, so that's like showing you like how you can do like compose your own workflow, right? It could be sometimes, for example, I did a transformation after the auth, right? But it could be like something we see quite often is people use like, I don't know, API keys or bearer tokens, let's say bearer tokens. And before they were sending the header with the value bearer space the token, and I don't know, they decide they don't want to do that anymore. They want to do just the token, for example, and you want to keep it compatible with previous clients, then you can do transformation before the auth in that case, right? So that if I don't see bearer, then I add bearer before, you know, these kind of things to make it like backward compatible. So let me delete all these rules for rate limiting. And let's do another last example, which is about web application firewall. We got like this request when we had this log4 shell. There have been the other one like recently, I never remember all these names, but the one here was quite interesting. So you had this ability to attack like Java applications based on a vulnerability. So everyone was kind of in a panic mode. I need to update all my applications very quickly because otherwise someone can, you know, use this vulnerability, right? But the good thing if you have an API gateway is that you can say, okay, I will apply this OAuth rule so that at least the attack will not be able to come from outside, right? Still, it can come from inside if I have another service running in my cluster trying to attack my Java service, it could still do it. But the chance that it will happen is quite low compared to coming from outside, right? So if I can protect at least the request coming from outside, then that's quite nice, right? So I'm going to create this policy here that it's just our web application firewall is really just based on mod security, so you can take any mod security rule basically and apply it, and it's running directly in Envoy. And now I update my root table. You see I change the label WAF equal true because I say I want this rule to be applied to the root that have this label. And now if I try to abuse it, and the thing is that I don't remember what is the endpoint, but I'm going to try to figure that out. So it should be like that, I think. Yes, you see, log4 shell malicious payload, right? Because if I still send a request like without this header, right, then I'm fine, right? It's just protecting when you have this this attack. Okay, so yeah, I hope you got the idea, right? The idea again is you can have like your services running on Kubernetes and you want to securely expose your application outside of your cluster and you don't want the application teams to implement all these things by yourself. You can just deploy like a standard API gateway. If you want also to cover like the security between services, then you need a service mesh, and you can also combine everything together and get this nice ability to secure both the edge and the service to service communication, right? So that's I think all I have here. And I kept some time for questions, but also, as you've seen, right, I'm using like some instructions there that are a workshop. So we have this workshop that we do regularly on our different products, but we also have like workshop that we do more to educate people on technologies. So we have like, for example, 3 different workshops on Istio, from beginner intermediate and experts. We have some eBPF workshops. We have like GraphQL workshops. So we have like many different workshops. I really invite you to take a look at that. If you go to our website in the events page, you'll see where we are, but we'll see a lot of these kind of, you see, hands-on workshops that you can attend for free and learn more about these different technologies. So that's all for me. I hope it was useful.